Welcome to a lesson with Dr. Powell. Let's take a look at a function and its derivative. So this is a function of two different variables, x cubed plus 2xy plus 5y cubed. Now, we're going to think about the derivative as being some kind of a function, so at a particular point, where we input run and we output rise. The run is going to be a vector because it's going to be it's going to be like a change of x and a change of y. And the rise is simply going to be just the change of the output, which is a single number here. So we get a kind of a change of z based upon that change of x and that change of y. And what this is going to be, this function from run to rise, is effective on the tangent plane. Namely, this is a surface of some kind in space, and at a particular point, this surface looks a lot like a flat plane. We call that the tangent plane. It's going to look like that. So what we're computing here for a given run is the rise actually on the tangent plane itself, the rise on the tangent plane. So now how we compute that is we think there are two inputs, so there are two columns. There is one output, so there is one row. So output rows and input column. That's how we kind of base off the size of the derivative. The derivative we're going to write down as a matrix. So the inputs correspond to columns, outputs rows. Now, what do we put right here? Well, for this particular output, which is z here, we're going to find how fast z is changing per this input. This input right here, let's suppose, is x. So per x, how much is this changing? If we assume that in the other direction is held constant, the y is held constant. So if y is constant, then we're going to treat it as a constant here. So then what we would get, maybe we'll write it a little bit bigger here. We would take the derivative of this with respect to only x, y is constant. So only x, that would be 3x squared. Remember, y is a constant, so this is like 2y times x. 2y is the constant, so the derivative is just 2y right there with respect to x only. And then here, that's just a constant, so it's just 0. So this right here is the derivative with respect to only x. So this is like the rise in the of z. This is the rise of z in the x direction if the run is 1. Kind of that's the idea there. Or in other words, it's the slope in the x direction. So with an increase in the x direction only, this is the ratio of this to that would be this. Now, since this is a tangent plane that we're working with, the actual rise over run is the slope there. So it's the slope of the tangent plane in that direction. Now, to get the slope of the tangent plane in the other direction, and we don't use a comma, right? Because this is a matrix, so we want to just have a big space. So then we would take the derivative with respect to y, holding x as a constant. So then you would end up getting 2x, that's the coefficient of y there, and x cubed is like a constant. Then you'd get 15y squared plus 15y squared. So then what is this? This is the slope of the tangent plane in the y direction, all right? From a particular point, x, y. Okay, so using that idea, this is like the derivative, and let's kind of think about a point. Let's suppose we take the point 1, 0. So at x is 1 and y is 0, then that means that this derivative would look like the derivative of this function f would look like 3, and then we put a space in a matrix here, and then we have just 2, so 3, 2. So 3, 2, so at the point 1, 0, 3, 2 is the derivative. How does it work? Well, it tells us how to compute rise if we know run. So what if the run from the point 1, 0, like what if we start at 1, 0 and we want to move just a little bit, maybe like to the point in the XY plane, like 1.1 comma, maybe 0.3, then it looks like our run here is 0.1 in the X direction and 0.3 in the Y direction. So this will tell us what the rise is from that point to this point. What's the rise? So we can compute it. So we say, and the way we compute this is like taking a dot product. We have 3 times -1, or times 0.1, sorry, 3 times 0.1, said the wrong thing, plus 2 times 0.3. And then that becomes 0.3 plus 0.6, which would be 0.9. So we just determined that as we move from this point to this point, we actually know what the rise of the function is. It's 0.9. And we got it from understanding what the derivative was of the function at the point 1, 0. It's this matrix 3 space 2. Thanks for watching.